first thing I'd like to say is that we live in quite a fantastic time when it comes to AI, when it comes to big data. And what is happening is truly unprecedented at many levels. But the level which touches us the most is the democratization of big data and AI, which is now a reality. And I'd like to take at the beginning a moment just to appreciate how deep this change is compared to just a few years ago. And this is just an example, of course. It's a big one, it's Google, we all know it, but there's others. But the availability of these technologies is brand new. That didn't exist before. I mean, I've been in the domain of artificial intelligence since my studies in the early 2000s. And these type of technologies were not even things we could dream of having. Now, that doesn't mean that from an algorithmic perspective, we were not doing very interesting things. We were. But yet, to have this type of infrastructure available at hand, at low cost, for any company, including SME companies, that's totally unprecedented, that never happened before, and that opens completely new possibilities. And that's truly fantastic. We can even see from Google Cloud themselves the fact that it's not only that this is available for SME, that actually SME are adopting these technologies much faster than the big ones. Which is kind of counterintuitive because it's like the big ones are actually in the process of trying to do big data and AI for a much longer time. Why would they adopt this new infrastructure slower? Well, I mean, to start with, they don't start from scratch. They have decades of legacies, which they want to migrate to new ways. While for the SMEs, that's brand new, that's greenfield. They were not doing anything before. And they can just jump into it, and they do it immediately with the state of the art. So that's truly fantastic times for us. Yet, according to Gartner, there's over 85% of big data projects which fail. I mean, that's a staggering number. And by failing, it means they are abandoned. It's not that they don't go well. No, they're just like, okay, stop, we tried, we'll find another way. And that's puzzling. So as positive the first part is, that's really puzzling because as long as this is a reality, we cannot build. It falls apart. 15% success rate is not enough. Even if we can say, yeah, well, okay, but with this 15%, we maybe have exponential success. Okay, fair enough, maybe sometimes. But yet, it's not a sustainable model. It cannot continue like that. And what's interesting is that Gartner points out very clearly, it's not about the technology. The technology is not the reason why we have this failure rate, not at all. So, it's not because Google, Amazon, and many companies, including ours, are doing a bad job in developing this or that technology. The problem is coming from somewhere else. So I'd like to take a few minutes to think about where is the problem coming from, even before to start to think about how we could solve it. And I have here three nice examples, three little stories which I'd like to start with. And the first one I like very much. The first one is about Lego. And in the early 2000s, what Lego did is a huge big data project. And they used a lot of data to try to address and identify why the customer base was shrinking. Which sounds weird now, because with the Lego movies and us, I mean, they are bigger than Mattel now, so I mean, they are huge. But at the time, their customer base was shrinking rapidly. And so they used big data in order to try to learn what was going on. And they basically tried to understand emotion with data which didn't reflect emotions at all. And what they concluded, more or less out of evidence of revealed behaviors, let's say it like this, that the millennials just had a short attention span, wanted to have instant gratification. And then what did they do? They started to be much bigger, much simpler Lego blocks. Because they're like, well, then you achieve a structure which is, interesting and you can show and you can be proud of much faster with less effort. But instead of helping them, not only did this endeavor cost them a lot of money because they had to, you know, it's like they had to change a lot of their models and how to build them. Not only did that cost a lot of money, the curve was going down even faster after that. So they were even losing their customer base faster after this big data project. And then they took it in another way, which you know, kudos for them for doing that. And they said, okay, well, let's stop that and let's go put teams of researchers meet as many kids in family situation as possible. And what they realized there is that actually, for the vast majority of their potential customer, the joy to be proud of having done something difficult was far superior than the feeling of simplicity and instant gratification. But that was not in the data. And that's one of the big problems with the idea of big data, is the idea that because it's big, the data must be there in the way that we need it. That's not the case. That's not the case, at least all the time. And very often, data do not reflect, at least in the way they are, emotions. And we need to understand emotion in many situations to improve, for instance, sales results. So that's one reason. There's another little story which is interesting, and I don't know if you know about that, but quite a few years later, Google did a quite big project with the US government for health and so on, to try to predict flu epidemics, relatively regional, which is a big deal. So, okay, and what they did is that basically they took the idea that, which was so far quite relevant in the data, they took the idea that when people are searching for flu-related topics, then it could be an indicator, an even regional indicator, about whether there would be a flu epidemics going or not. And that was basically promoted as one of the big data success at the time. Except that they spoke a little bit too quickly. The system was not able to predict flu epidemics at all in practice. And basically, over the 112 days of prediction, there was more than 100 days of misprediction. So it's not like, okay. And what completely stopped it, and Google just like turned it off, when a scientist demonstrated that he had a better model of predicting flu epidemics looking only at the temperature. And that data set was actually more accurate than this project. And then they did, and well, you know, that's also interesting to think about it. And Google, I mean, they are the leaders of AI. So I mean, if they are doing it wrong sometimes, how couldn't we? Well, I mean, the reason they did it wrong is that they missed one, which is a very common problem. They missed the difference between correlation and causation. Well, when the government was announcing an epidemic, that had a huge influence on what people were doing. So there was a correlation, but it was the other way around. The causation was not there at all, and the project showed it very, very strongly. And that's very often also something that we could wrong. So to summarize, the data that we want is not necessarily the data that is there, and the correlation we see don't necessarily bring the causality that we think it has. And the fact that you have a data set of 100 cases, 1 million cases, 1 billion cases, 100,000 billion cases does not matter so much. And that shows more fraud of us to think that because it's big data, then the solution is there. No, it's just a lot of data. That's the only thing that means, a lot of data. And that's exactly the third point, to say, well, not all data is useful. Don't think about your data warehouse as a junkyard. It's not because you drop more stuff there that it will make your business better. It doesn't work like this. It might be that some of these data are useful. It might be that you need a lot of them because you cannot learn from smaller data sets. All of this, fair enough, but it's not guaranteed at all, at all. And 85% times it is shown that it is not working. So we have to think about that. We have to think about these aspects in order to figure out what to do. Now, what Gartner shows also is that basically the big challenges since the arrival of big data didn't change at all. And that also requires a bit of reflection. So, okay, well, how come, with all of these kind of hype around big data, the key problem is exactly the same as before big data? And what is the problem? Determining how to get value from big data. I think we could take a presentation from the 90s and say, okay, what is the problem you have with your data? You can just remove big, and you can say, yes, that's still the number one thing. So that's the number one problem, is that big data does not necessarily answer to that question. And then comes the skills, and then come the governments, and then far lower come the infrastructure and architectural issues. Again, nothing wrong with saying we need to have state-of-the-art architecture, state-of-the-art technology. But we have to get to leave away the idea that these algorithms and these platforms are the guarantee of success. They simply are not. They simply are not. Oh, sorry. Now, I know this slide is a bit more complicated, but it's very, very important as well. Because that's the other side of what's going wrong systematically in AI. That's not specific to big data, that's specific to any AI situation, but that matters a lot with big data as well. The idea is that you have two worlds, and these two worlds are quite separated. You have the worlds of the data scientists, who build basically their predictive models, different types of algorithms and so on. And then you have the world of the IT engineers, who are managing systems, managing websites, managing e-commerce websites in our case, of course, as well as. And these are really different people. They don't speak the same language. So first you can say, well, they don't speak the same language because these people use R and SAS and Perl and Python, and these guys use Java and .NET. And so, okay, you can say, well, they don't speak the same language because they don't use the same technologies, but that's much, much, much deeper than that. They don't understand each other very well at all. And that's a big problem, because that means that this guy creates a new model and says, you know, that's cool, I create a model, I'm able to learn and predict based on some clicks whether the gender of the person, and based on that gender I'm able to predict this and that, and that's what should change and what we show to the people. Okay, great. So how do we bring that to the website? Well, I mean, the website is under the control of these guys, not of these guys. So okay, so here is a document where I explain my scoring system, or even more complicated, my predictive model, because sometimes you cannot just create a decision tree and say, well, this is my prediction model. No, you have to actually really provide the model itself. Then it tries to integrate, and then it does custom codes. And these models are extremely sensitive to very, very, very small difference in the input. So it's immediately off whack, it doesn't work at all, we don't understand why. And it's not only that it's hard to correct, it's that they don't figure out between them what's not going on. And that can go for months. But that's a big problem. Because if you invest in big data, if you invest in artificial intelligence, in these guys, but then when these guys want to bring the value of what they do live, you have to go through that process. Then you have also a big problem. It's not actionable. And that's a big thing. That means that without solving that, all of these big data and AI aspects are fundamentally, from a business perspective, totally not actionable. And that matters. That's quite a big thing. So, now, what can we do about it? Well, the thing is that we cannot simplify. It's not possible. We cannot say, well, you know, let's just use simpler techniques to achieve the same thing. I'm discussing that with my customers in e-commerce all the time. Say, yeah, but you know, maybe we don't need AI, because maybe with just the right set of rules, the right set of configuration, the right set of things, we can really achieve like 80% of the result. But actually, that does not work. That doesn't work at all. Because if you remove this complexity from the game, if you try to solve these things in a more simple way, you don't fail at 10%, you fail at 90%. And I like this diagram because it shows that, well, if you think about the way that your customer journey iterate and go towards the goal, which hopefully is that they buy something, and they buy something many times for as value as possible, then that journey is going to be something like that. Now you can say, well, you know, that looks like a funnel. I know marketing funnel. There is a base of how to manage marketing funnel. So why don't we apply a marketing funnel? Well, because then you actually lose that picture. You just see the funnel. And you're like, okay, well, you know, I'm here, and the people there, and what do they do? It's like, no, because their journey, the way they iterate, all of these things defines something very important. It defines many things, but one of the things which it defines is their mind states. And if you're in the business of selling, understanding mind state is a big deal, because that might be the reason why you manage to sell or not to sell to your customers. So that's very important as well. Now, how do we get valuable insight out of customer journeys? And that's the question we've been asking ourselves for many years in my company. How do we get a valuable insight of customer journeys? Considering all of these problematics, considering this fantastic opportunity to have these new technologies, these new platforms, this new AI, this new big data. I mean, all of this at our hands at a fraction of the cost from a few years ago. I mean, that's amazing. But at the same time, these challenges. And we've been thinking about that a lot. And we believe that there's at least a few things, and we don't pretend that we solve everything, but we believe that there's a few things which the industry is systematically getting wrong, mainly because they don't think about it in the complete extent. So let's think a little bit about what we call click path. So a click path is, in the overwhelming majority of the cases, what is used by data scientists to define behaviors. So it's important to know what it is. And what is a click path? I mean, it's super easy to understand. It's a list of URLs that the person has done in his visit. So he went to this URL, and this URL, and this URL, and this URL, and this URL. And that creates a path. And a lot of companies says, yeah, and that's the journey. So the journey throughout sessions, throughout visits, throughout cookies, throughout visits, throughout devices, all of these things we have to find, but this is the path. And that represents it's the path. And if you want to do customer journey optimization, which is of course a big important part of what's at stake here, then you have to understand the path. But there's a problem with that, is that this is pretty much the way that one path looks like. And that's where the problem starts. Because and that's really worthwhile, I always do that with my customers. I look at a few behavior paths of specific customers. Just like, even randomly. What I've realized is that everyone is always amazed at how chaotic that looks. Now, it doesn't mean that it's chaotic for the person going on the website. It doesn't mean that. For him, it feels completely relevant. But from an outsider, just having this URL list as the data to learn from. But that's a big problem because it's completely chaotic. I go here, I do a search, then I go back to the start page, then I open 2 tabs, then I continue what I do here, then I continue what I do there, then I go back, then I receive an email, then I come back, then I see that. It's completely chaotic. Now, think about what is the idea of big data? Well, no problem. Let's put a lot of this mess together and put it in a huge bowl of stuff. And now everything will be clear. Okay. Now, does it mean that it's pointless to analyze this huge mess? No, not at all. There's nothing. It's not to say that's completely pointless. Maybe there's some patterns of color, patterns of text. There's patterns that could be found. So it's not that you can do nothing with that. But let's be frank. If we're trying to model customer mind states in a kind of neuromarketing-oriented type of way, good luck. Good luck. And that doesn't matter. If you're the most brilliant data scientist and artificial intelligence specialist for Stanford, from MIT, from whoever, that's the data which are fed to the algorithm, and the algorithm has to do the best it can with the data which is fed to it. Okay? Not to say there's nothing to do, that's not what I'm saying. But there's a real problem there. And when you think about SMEs who don't have billions and billions of visits every day like these big companies, then there's even a problem of size of data. But even if an approach could maybe come to a conclusion with billions of them, a lot of our customers will never reach this amount of data, ever. So what could they do? Now, what we have thought a lot about, and what we have built a lot of ideas around, is the concept of what we call narratives. And the idea is relatively simple, is that instead of considering that the journey is a click path, we think it's superior and better to think about it as going through the narrative of a storytelling approach. And when you think about it, that's exactly what a website should do. Through the content it's displaying on one page when you're scrolling down, as well as between the pages in a consistent way, in a coherent way, until you reach a certain goal, but also ad perpetuum. because the company wants to keep you as customer forever. So it's a never-ending story, which is a personalized never-ending story. And that's a much better way to think about it. Now I say, okay, that's interesting. But that means that if we're able to build a website like that, and to work with the customer instead of just saying, oh, here is some content, here's some content, here's some content, and maybe you're also interested in this, and maybe you're also, no. To say, no, we go through a flow, a storytelling flow of pieces of content, which don't have to be completely esoteric. It can be just a banner, just 2 or 3 products, some customer quotes, again some ratings, then again some products, and then some category pieces. I mean, it can be completely normal things that we see on every website, but done in a way that follows the structure of a story, a personalized story, an individual story. Then something changes. So what does change? By the fact that the company starts to create its content in a story-oriented flow mode in order to be able to have pages which are personalized, which are staying a story which is different for customer from Facebook than comes from Google, customers who are long-term customers compared to new customers, and so on and so forth. It basically defines in a structured way what appears on the page. That means that for the same page, this is what person A will see, this is what person B will see. Yes, here, because I don't have the time, but basically here, it's just an example to say, well, maybe it's good here to show banner first and then vouchers because this person is a member and this one is not. But this is just an example. Overall, that means that for the same URL, we have completely 2 different components. So we even have a bigger problem with our click path because then the click path represents even less information because the page is personalized and dynamic. That's the first thing. But it's also an opportunity because that means that if we can track in a structured way what the person sees and how it interacts with the content of the journey elements, then we do not have only click path anymore. Then we have something completely different to work with. We have something structured, which is defining, and typically here we use quite advanced JSON scheme architecture. So basically we have highly structured data, highly tuned for big data analysis about what everybody sees on every page of every website, so that the structuring doesn't need to be done from the ground up, from the mess of low-level data, but that we have big data which are structured to start with, to start the analysis with, to start the tuning with, to define better rules about whether that's a good idea to separate the behavior from members this way or not. And that changes the game in a big way. And the other point is that, well, that's the first part of the story, to say, well, okay, well, if we have really much better quality of data, whether we have a lot of them or not, hopefully we have a lot of them, so I have nothing against big data, on the contrary, then we can now solve a bit part of the problem of what can we do with this data. But then there's still the problem of actionability with my slide from before, to say, okay, but that's great, but now we want to have and we need to have something which is actionable. And in our world, I know in many industries it's more complicated, and to some degree it is there too, but to simplify, we really have 2 main actionable actors. We have the data scientists and we have the marketers. These are the 2 fundamental forces who want to be able to act with the system, if possible, either in real time or close to real time, and not to go through the IT in order to change anything in the system. So we need to have a system which is able to, through reporting for these guys mainly, through structured data for data analysis for these guys mainly, that both of them can extremely efficiently act and change the system. And there is something interesting which has been developed and didn't get the interest that honestly it should have for quite a few years. And that's called PMML. PMML stands for Predictive Model Markup Language. And the idea is nothing else than the fact that any type of data learnings with any type of algorithm does not matter, in any system for that matter, can be exported in a universal format for trained predictive models. And then what we did is that we integrated the capacity, as well as many other type of data, of course, to load them in our real-time infrastructure. and to play them, potentially in a testing mode, like A/B testing mode, and so on and so forth. But that's a big deal again, because that changes completely the picture from before. That means that the data scientist, he has a machine learning API that he can use to load his learnings, try whether, when he found a prediction which works with his data set in order to do improvement, actually works in reality, without going through the IT people at all, because that's part of what the system does. And of course, it's a mutually feeding idea, meaning that the more I do that, the more it alters the structured content of what people see, which is tracked and reported to the people so that they can fine-tune their learnings with new data that they didn't have before. That means that data scientists can do exploratory models to say, well, I don't know what I need to know in the data, but I'm changing what this website does in order to get the data that I don't have in the structure that I need, so that I think I can learn what I can learn. And that again makes a big difference. And so, as a conclusion, basically what we're all trying to do is that we're trying to build an infrastructure relying on big data, opening all of the possibilities of AI, not just a few sets, not to say, oh, this algorithm is no, just all of the possibilities of AI, in order to be able to influence emotions. And we believe that should be possible, not with a 85% error rate, but with an 85% success rate at least. And that's basically what we're trying to do. So I thank you for your attention, and I hope that the topic was interesting enough for you to maybe open some new ideas. Thank you very much.